Hi grade 9s. The previous section that we have covered is the equation section, and it's a really important section. And so this video is all about revising what we should know and maybe just jotting down a couple of notes looking at the section as a whole. So let's look at question 1. Question 1 says solve for x, which is your typical question for equations. Now, don't forget that the first thing I have to ask myself in any equation that I come across is the equation linear or quadratic? Now, we're probably a bit rusty on this at the moment, but linear means that I only have the letter x in it, or a or b, it doesn't matter what letter, but basically the fact that the exponent is 1. And a quadratic is an x to the power of 2. Now, sometimes, as you're going to see when we look at some of these equations, we don't actually know if it's linear or quadratic before we start. So sometimes we have to start, and then slowly as we figure things out, we go, oh yeah, I see, it's linear. So if I have a look at this one, for example, I see 16x and I see 8 minus 8x, and there's no ways that I'm going to be multiplying to get an x squared anywhere, and so immediately I know that this equation is linear. Now let's also remember that the approach to a linear equation means that we must get all our letters to one side. So all our x's need to be on one side, and generally I pick the right side. And then we get all our numbers to the other side. So after we've gotten all our letters to one side, we try and isolate the letter, which basically means we need to get all the numbers to the other side. So letters to the left, as I always say, and then numbers to the right eventually. So if I'm looking at this, for example, what I would do here is I say, right, I have subtract 8x here, which I don't actually want because it's on the right hand side. So if I want to get rid of it, I'm going to add 8x to this side, and I'm going to add 8x to that side. Now, to be honest, I do that in my head. What I've written in red, I do in my head. So my next line just says 16x plus 8x, which I've done in my head, is 24x plus 2 equals minus 10. Now, there's nothing wrong with actually writing plus 8x on both sides. As I say, I do it in my head. Now, the moment we've got our letters to the one side, we basically need to isolate x. Now, by isolating x, what I mean is you need to get rid of everything attached to x. So I need to get rid of this plus 2, and I need to get rid of this 24. Now, don't forget, you always get rid of what's furthest away from x first. So always get rid of what is furthest away from x. So by that we mean anything that is not directly attached to x. So what's furthest away from x will be something in a different term. So for example here, if I fill in my terms, plus 2 is the next term. So I'm going to get rid of that separate term by subtracting 2 on both sides. Again, I often don't show that. I just do it in my head. So in my head, I'm like, oh, subtract 2, it disappears. Oh, I subtract 2, I get minus 12. So I often do that in my head. Now I need to get rid of multiplying by 24. So I'm going to divide by 24 on both sides. And then I'm going to simplify that, because negative 12 divided by 24, most people want to say negative 2 out of instinct. But just be careful, it's negative a half. So that's a classic example of a linear equation. So just don't forget, the moment you realize it's linear, the idea is always get my letters to the one side, preferably the left, and get all my numbers to the other side. So basically I start with get rid of all my letters to the left, and then try and isolate the x. So let's look at some more examples. Let's look at b. Now I have put mark allocations in here. As you can see, there's 3. Where the mark allocation would be is I'd give you 1 for getting all your x's together, 1 for getting your numbers together, and 1 for your answer. So that's just where the numbers would go. Try and use your mark allocation as a guide as to how much work you should be doing. Okay, our next one says 6x equals 4x. Now the moment I see that, I say this is definitely linear, because there's no x squares, and therefore it must be just a linear equation. So I need to get my x's to one side, which means this 4x can't possibly be there. So if I just rewrite this for a second, I don't want 4x on the right hand side. So I'm going to subtract 4x on this side. You're welcome to do this in your head and not actually write it down. But 6x take away 4x is 2x, and 4x take away 4x is nothing. Now this tends to freak people out a bit for some reason. People start to go, oh gosh, but there's no value for x, I don't know what to do. Well, let's just carry on as usual. we now need to isolate x. So I need to get rid of the 2. It's multiplied by 2, so I'm going to divide by 2. Remember, you do the inverse operation. And 0 divided by 2 is 0. So it's not that there's no answer for x. The answer is 0. Now, let's just think about it for a second. Why is that definitely true? Well, what is 6 times 0? 6 times 0 is 0. And what's 4 times 0? Oh, it's also 0. So actually, that makes complete sense. Now, notice there was only 2 marks because you basically got your x's to one side and divided. It was quite quick. Okay, on to the next one. My first thought would be, now it's 5 marks, so I'm definitely expecting a little bit of work. My first question would be linear or quadratic. Now, if I'm looking at this, I just see x's, but it doesn't mean that when I multiply out, because I'm seeing brackets here, maybe I'm going to get an x squared. So I don't actually know right now if it's linear or quadratic. So the moment I see brackets and complicated things, I first ask myself, should I multiply out? Now, when we get to a couple of questions down, we're going to discuss this question a little bit more and when you shouldn't multiply out. Now, when should you multiply out? Well, there's 2 terms here where I need to multiply out, and if I divide into terms, which is very important, so I'm going to write that there as my next step, always divide into terms. I've got multiple terms here, and there's 2 terms where I could multiply out. And so this isn't a case of where we are going to get to in a couple of questions' time where it doesn't make sense to multiply out. So here it does make sense to multiply out. So if I multiply out 5 times x and 5 times minus 1, this is 5x minus 5 equals, now don't forget that 2, you can't do 2 minus 3. I deliberately made up this question because most of us will do 2 minus 3 and then distribute into the bracket. Don't forget that that 2 is a separate term. So that 2 has nothing to do with the minus 3. Now I need to distribute in my minus 3, so I get minus 3x plus 9. Now personally, I now realize that this is now linear because there are no x squareds even when I've multiplied out, which means I need to get my x's to one side. So I want my x's to the left. So the only x's that are in the so-called wrong place are these minus 3x's. So I'm going to add 3x to this side and add 3x to that side. So if I just neaten both sides up now, so on the left-hand side I've got 5x plus 3x, which is 8x, and I've got a minus 5. On the right-hand side, I've got 2 plus 9, which is 11, and minus 3x plus 3x, which disappears. Now, you don't actually have to write the purple. You can do that in your head if you want, and then you'll get straight to what my line is in blue. And now it's a standard linear equation. I need to isolate x. Don't forget we get rid of what's furthest from x first. So I'm going to get rid of the minus 5. Again, you don't have to write what I'm writing in blue. As long as you have, okay, so I've added 5 to both sides, so I get 8x is 16. So what I've written in blue is what I'm thinking. If you are feeling a little unsure, it helps to write it out, but you don't have to. Now I'm going to divide by 8 on both sides, which gives me x is equal to 2. Cool. Now those first 3 examples are pretty much your basic linear equations. This would be considered a fairly complex one because you're dividing into terms and you're multiplying out and then you're doing linear. So question C would be considered fairly complex, but it should be something that we're really comfortable with. So those first 3 examples were all about practicing your basic linear equations. Okay, so what are our next couple of examples about? Our next couple of examples are about the first thing we learned, the first new thing we learned in grade 9 equations, which is all about equations with fractions. Now don't forget, the moment you have an equation with lots of fractions, if you have one fraction, that's different. The moment you have lots of fractions, you need to find an LCD. So in this case, my LCD of 2 and 5 is 10. Now personally, what I prefer to do is I basically multiply every single term by 10. So I multiply each term by 10. There's lots of ways to kind of think about this, and they all end up being exactly the same thing. So if I do that, this is 3x over 2 plus 4 over 5 equals 2. Now, the only mistake which people generally make here is they forget to multiply every single term by 10. So if I multiply that by 10, and I multiply that by 10, I also have to multiply the 2 by 10, which is what most people forget. Now what happens here is 2 goes into itself once, 2 goes into 10 5 times. So I actually get 5 times 3x. And 5 goes into itself once, but it goes into 10 twice. I'm basically going 10 divided by 5, which is 2. So what ends up happening is I get this term, which is 5 times 3x, which is 15x. This becomes 4 times 2, which is 8, and 2 times 10, which is 20. Now, the moment I've done that, this goes straight back to being a really nice equation. So now I'm going to isolate x. I get rid of what's furthest away from x first. So I'm minus 8. You can do this in your head. I'm minus 8 on both sides. So I get the 15x by itself. And I get 12. So I should say equals. Then I need to get rid of the 15. And I'm multiplying by 15. So I'm going to divide by 15. Divide by 15, and so basically I land up with 12 over 15. Now I should never leave a fraction. That doesn't simplify to a whole number, but it does simplify because I know 3 goes into 12 4 times and 3 goes into 15 5 times. So as far as I know, I get 4 over 5. So try your best to just use your calculator to check if your fractions can simplify. So that was one of the first kind of fractional equation things that we learned. So hopefully that makes sense. Let's try another one. Again, 5 marks because it's quite a lot. The moment I see multiple fractions, I think my LCD. And what's the LCD of 4 and 6? Well, immediately I thought of 24, but hang on. 12 is probably the smallest number that both of those go into. It pays to find the smallest number because it means less simplifying later. So basically, if I leave myself a little bit of space to write this, I'm going to take every term and multiply by 12. Don't forget every term multiplied by 12. Now, this is a complicated one because there's 2 terms at the top of this fraction, so I'm going to use a bracket. Now, what happens is that 4 goes into 12 3 times, and 6 goes into 12 twice. So now I've got a little bit of multiplying to do. So this term's easy. That's 3x. This is also easy, 24. This is a little bit more tricky, and this is where most people go wrong, is they forget the brackets. And so they forget now that it's 2x and 8. So most people just write x plus 8 because they think that only the 4 is multiplied. So just be careful. It's actually 2x plus 8. Okay, now we're back to one of those, like question C, where we have an relatively easy linear equation. It does have x's on both sides, so I'm going to minus 2x from this side and minus 2x from this side to get rid of my x's. You can do that in your head. So I basically get x, because 3x minus 2x is x, and so I get x minus 24 equals 8. And then again, this part you can do in your head, but basically I'm going to add 24 to both sides, and so I land up with getting x is equal to 32. Okay, again, fairly complex, these equation ones. It's very easy to make a mistake, but hopefully this is making more and more sense. Okay, let's try another equation with fractions, just to make sure we know what we're doing. First thing I ask myself is, what is the LCD? Notice it's 6 marks. So it's sometimes a bit daunting because you're like, oh my word, it's 6 marks. But it's very quick to get up to 6 marks because you're doing distribution and you're multiplying. So let's have a look. My LCD of 5 and 4, I think, should be 20. So if I write this out with a little bit more space, so x plus 5 over 5. Now notice that's multiple terms at the top, so I'm going to use a bracket. Plus 2x minus 3 over 4, and again I'm going to use a bracket, equals 2. So I'm going to multiply by 20 in every single term. Don't forget that means the 2 as well. Multiply by 20, multiply by 20. Now actually sometimes I find it easier, interestingly enough, to write this on the left hand side, simply because then distribution seems more logical. So let's see, 5 goes into 20 4 times, and if you've got the bracket, you can't make a mistake. 4 goes into 25 times. So if you've got the bracket, you will very easily know to distribute. So I get 4x plus 20 plus 10x minus 15 equals 40. Now this is a linear equation. It needs some neatening up. So that gives me 14x, and that gives me plus 5. I always like to neaten it before I work with it. It makes it much easier for me. Now I'm going to get rid of what's furthest away from x first. So that's, I'm going to minus 5. You can do this in your head if you want. But if I minus 5 on both sides, I get 14x is equal to 35. And then if I divide by 14, I hope I haven't made any mistakes here. If I divide by 14, I get x is equal to now 35 over 15, over 14. 35 is an odd number, but 7 goes into it. Oh, great. So definitely will simplify. You can always use your calculator. But basically 7 goes into 35 5 times, and 7 goes into 14 twice. And so that actually simplifies down to something quite nice. Do not be afraid if answers land up being fractions. There's nothing wrong with fraction answers. Right, so last question with a fraction, that is g. Now g is only 2 marks. Have a look at that, because this is quite weird. This would be considered a problem-solving question. So have a look. We've got 4 over x equals negative 8 over 6. Now there's 2 ways to do this question. If we weren't pausing to think and we were just kind of launching, I'm looking at them going, oh, I don't want to do an LCD, there's an x, I'm so confused or whatever. Well, why don't I multiply by, let's choose just x. If I multiply by x, it means my x disappears. So I'm not even thinking about LCD, I'm just thinking I don't want an x at the bottom. So this is very weird for us. Basically what happens is my x's would cancel and I'd land up with 4, and here I'd have minus 8x over 6. Okay, now that's a nice question. There's nothing wrong with that question. So notice we'd never seen something like this before. Even in all the examples we did previously, I'd never thrown something like this before at you. So don't be afraid in an exam or a test just to kind of see and try and see where you get to. Now what I would do is I'd multiply by 6. So I actually then get 24 is minus 8x, and I divide by negative 8. And negative 24 divided by negative 8 is negative 3. And I get x is equal to negative 3. So notice we hadn't done this before. I decided to abandon the lowest common denominator because I saw an x in the denominator and I got a bit confused. So let me just go over, you know what, I want to get rid of the x in the denominator, so why not multiply it? You can't possibly go wrong. Okay, now, or why was this only 2 marks? Well, if you have a look at this, 4 over x equals negative 8 over 6. Well, let's just think about this for a second. There's a negative on this side. So far, 4 is positive. So you've got to be dividing by a negative. X is going to have to be negative if this answer is going to land up being a negative. Now, if I have a look, basically this is a fraction. I've considered the negative, so that's done. What is 8 over 6? What does that simplify to? That simplifies to 4 over 3. So 4 is there, which means x must be 3. So I could go straight to the answer by just like kind of thinking about it. Now you don't necessarily always, you won't necessarily always be able to do that. So it is quite nice to see the whole idea of multiplying by x and not being afraid to do that. Okay, so basically that's the kind of end of linear equations revision and equations with fractions. So now we're moving on to a different type of revision. Our last couple of examples are all about quadratic equations, which is the big new stuff for grade 9. Now a quadratic equation is when you have an x squared and then there's a certain kind of process that you follow. Now, if I look at this question, I wouldn't immediately say it's quadratic because I'd say, oh look, a bracket and a bracket. Oh, I can multiply out. And so what I might be tempted to do is multiply out and go x squared plus 2x minus 3x, binomial times a binomial, minus 6. Now the moment you do that, you're like, hang on, this is quadratic. So if I simplify it, I get that, which is looking good. Now what's the whole plan for a quadratic? The whole plan for a quadratic, which you pretty much have to know by heart, is make one side equal to 0. First step, make one side equal to 0. Second step, factorize. Basically, you want two factors to multiply together to give you 0. So you want to get a bracket times a bracket equals 0. This is what you want. Why? Because I don't know if you remember from our discussions about this. Basically, if you have two things multiplying together to give you 0, the only way this is going to work is if one of those things is 0. If one of those things is 0, when you multiply, you get an answer of 0. So what happens is you actually get two answers, one from each bracket. Now, that's why we need to pause here. Make one side equal to 0 and then factorize. If I have a look at what I did, I multiplied out. Now guess what I'm going to do? I'm going to factorize, and when I factorize, I'm going to go straight back to where I came from. So was it sensible to multiply out? No, that was not sensible. So when we're saying, should I multiply out, always remember what your aim is. Your aim is you want to get two brackets multiplied together to give you 0, two factors. So if you already have that, don't go and multiply out. So if you have a look at this, just think about what you want. That is what I want. Now if I scroll up to example C, where we did multiply out, let's compare it. If I look at this thing here, did you have two factors multiplied together to give you 0? No. And if you don't have two factors multiplied together to give you 0, it makes complete sense to multiply out. So let me just say this again when we look at this example. Do I have two factors multiplied together to give me 0? Yes. So don't multiply out. Basically, all I need to do here is say, oh, that's great. So either x minus 3 must be 0, or x plus 2 must be 0. So then I add 3 to both sides. So I get 3, and I subtract 2 from both sides, and I get minus 2. So don't forget there's two answers to a quadratic equation. Okay, let's try another one. Do you have two factors multiplied together to give you 0? No, you don't. So my first step, this is definitely a quadratic. I'm sorry, I should have said that. It's quadratic. So my first step is make one side equal to 0. You would notice that I'm trying to, gently ease us into this revision. So that has been done for me. My second step is to factorize. Now again, we're probably a bit rusty on factorizing. So what is the first step when we factorize? Highest common factor. Second step is we look, is it a dots? Third step, is it a trinomial? So if I look at this one, is there a highest common factor? Absolutely, because 3 goes into 3 and into 6, and x is common. So 3x multiplied by x will give me 3x squared, and 3x multiplied by minus 2 will give me 0. So now what I've done is I've built two factors multiplied together to equal 0. So now either 3x must be 0, or x minus 2 must be 0. So after you've factorized, basically each factor could equal 0. So this is where I start getting like a branch, and I get two answers. So 3x could be 0. How do I solve this? Well, this is a little mini equation, a linear equation. So if I divide by 3 on both sides, 0 divided by 3 is 0. Or I add 2 to both sides, and I get 2. And so there's two different answers. So again, there's a summary of quadratic. Once I know it's quadratic, make one side equal to 0, factorize, and give each factor a chance to equal 0. Okay, let's try another one. Question J. It's quadratic. 3 marks. What's my first step? Make one side equal to 0. That's been done for me. Second step, factorize. Is there a highest common factor? Well, I've got, so I should put a C there, so it says factorize. No, I don't see any highest common factor, and it's 3 terms, so it's a trinomial. So let's remind ourselves how to factorize a trinomial. So first of all, we put in what's obvious. So obviously, you're going to need an x times an x. So that's the first thing. Second thing is you look at 36. What are my factors of 36? Well, there's 36 and 1, which is highly unlikely. There's 18 and 2, again, highly unlikely. There's 4 and 9, that could be possible. There's 3 and 12, I think that could be possible. There's 6 and 6. So there's lots of options here. Okay, so lots of options. Next thing, let me look at my sign. This is a negative 36, which means my signs must be different. One must be a plus and one must be a minus, because that's the only way to multiply these two together and get minus 36. Next step, look at my middle term. How can I possibly get 9? Let's not worry about the negative, just 9. Well, 36 and 1 can never add together to give me 9, so that's out. 18 and 2 cannot add or subtract. Remember, you're adding the middle terms to get 9. No. 9 and 4 can get me 5 or 13. That's not helpful. 3 and 12. Oh, I think that can give me 9. Now, don't forget, my signs must be different. So I want negative 9. So I think I need negative 12 plus 3. So negative 12 plus 3. Now, personally, I would multiply that out on my question paper or scrap of paper to check if you get this right. And so my last thing is basically each of these have to have a chance to equal 0. So either x plus 3 must be equal to 0, and I subtract 3 on both sides, or x minus 12 must equal 0, so I add 12 on both sides. Now that's considered a fairly difficult trinomial and a fairly difficult quadratic equation. But just follow your steps. Only 3 marks. So basically 1 for factorizing and 1 for each answer. Okay, next one. Second last one. The moment I see an x squared, this is quadratic. So that's decided for me. My first step is one side equal to 0, which has not been done for me. So I need to minus 6 on both sides. So I get x squared minus 5x minus 6 on both sides equals 0. Next, I'm going to factorize. Again, this is a trinomial. So let's revise. I put in my obvious. Obviously, it's x times x. Now let me look at my factors of 6. My factors of 6 are 6 and 1 and 2 and 3. Let's look at my signs. My signs must be different because it must be a positive times a negative. So basically I need different things, and these different signs and these middle terms have to add to negative 5. So if the signs are different, so this could be plus 6 minus 1, which would give me plus 5. Or it could be minus 6 plus 1, which would give me, guess what? Minus 5. Now just be a little bit careful of 2 and 3, because lots of people will pick 2 and 3 here because 2 plus 3 is 5. But if you were going to need to get negative 5, you would need minus 2, minus 3, which is negative 5. But careful, my signs are not allowed to be the same. So that's why I know that the answer has to be plus 2 minus 3. And so finally, I know that either x plus 2 must be equal to 0 or x minus 3 must be equal to 0. So I minus 2 on both sides and I add 3 on both sides, and I get 2 different answers. Okay, last one, question L. I have a look at this. Is this linear or quadratic? I don't know. I don't know right now because I see an x, but I also see a bracket, so I could multiply out. So now my question is, should I multiply out? And when you ask yourself, should I multiply out, you have to say to yourself, well, the only time I mustn't multiply out is if I have 2 factors multiplied together to give you 0. So in this case, I do have 2 factors multiplied together. I have x and x plus 4, but this is not 0. And so the moment that's not 0, I should multiply out. So do I multiply out? Yes. Because I do not have 2 factors multiplied together to equal 0. So I'm going to say x times x, which is x squared. So the moment I do that, I know it's quadratic. Plus 4x equals 5. So I have multiplied out. Now I still haven't fulfilled my first step. My first step is get one side equal to 0. So I'm a little bit closer to that, but not yet. So I'm going to subtract 5 on both sides. So it's minus 5 equals 0. And now I'm going to factorize. And the moment I look at this, I checked for a highest common factor and there wasn't one. And I see a trinomial again. Now this is a quite nice trinomial because obviously it's x times x, but what is the only options to multiply together to give me 5? Is 5 and 1. There's no other option. Now, once again, I didn't mean to do so many different signs, but once again, my signs have to be different. So 5 and 1 has to be a plus and 1 has to be a minus. But I want the middle to be plus 4. So I think it's plus 5, take away 1. Again, I always multiply it if this is a test or exam, either in my head or on the question paper, to make sure I'm right. So finally, either x minus 1 must be 0, so add 1 to both sides, or x plus 5 must be 0, so subtract 5 from both sides, and I get 2 answers. Now that's pretty much every type of equation I could possibly think of to quickly revise. It's a lot of work that we did in the last section, and so this is quite a brief summary, but it's really important, this section, and so I'm hoping this will just help bring back those memories. Now the last thing we did in the last section, which I've just put one question in on, is we did some word sums. So let's have a look. At the end of the netball season, Petra had scored X goals. So let's write that down. Petra had scored X. Sandra had scored 3 goals less than twice Petra. So Sandra, first of all, let me just focus on the twice Petra. Twice Petra would be 2x, but she didn't score 2x. She scored 3 goals less than this. Now, less than means take them away. Okay, and I haven't even looked at the question yet, so I don't know if I'm doing what they ask, but I'm just reading it and making sense of it. Georgia had scored 15 more goals than Petra. Not 15 times, 15 more, so x plus 15. Together they scored 60 goals. Now, I hadn't even read the question, but the first question says, write down an expression for the number of goals that Sandra and Jorah had scored, obviously in terms of x. So that's quite a useful phrase. In terms of x means using x. So there we go. Now, the next question said, use an equation. So not just guess it, use an equation to solve for x. Now, basically, together they scored 60. So basically, Petra plus Sandy plus Georgia, and I don't think I spelled Georgia right in the previous G, or that I, there shouldn't have been there. Georgia has x plus 15, and together they give you 60. Now this is quite messy, so let me just neaten it up. X plus 2x is 3x, plus x is 4x, minus 3 plus 15 is plus 12. And this equals 60. So either in your head or on the page, I'm going to subtract 12 from both sides. And so I land up getting 4x is equal to 48. And so finally, I'm going to divide by 4 on both sides. And if I don't get a whole number of goals, I know I've made a mistake, because Petra can't score 2.5 goals. But I get 12 goals. And now that's what I needed. They didn't say how much does Georgia score. They said solve for x. So Petra scored 12 goals. Okay, now obviously word sums can possibly be a little bit more tricky than that, and they take a little bit of practice, but hopefully the more you practice, the better you get. So basically that is a quick summary in a couple of minutes, well 35 or so minutes, of everything we'd learnt in equations. I really hope that it helps to summarize everything for you and to jog your memory a bit.